dude, did you hear the news? Many farmers are suffering by this COVID-19. Many of them are nothing to do. I'm worrying about them.
Yes bro, I also heard that. Don't worry bro, that's why do this project. So this will be very helpful for farmer.
Hi Kashvini. How are you?
I am fine. How about you guys?
We are fine. Why you looking so sad? Is anything problem?
Yeah, I'm worried about my father. He is a farmer. Due this pandemic situation, he can't do farming. So he's so confused about what to do next.
We also talking about this. But don't worry Kashvini, we have a solution for this.
Oh really? What is that?
Come with us. We show that.
This is our project. Hydroponic smart farming.
Wow, it's great. Tell me more about this.
Smart farming is a concept of managing agriculture using technology such as IoT. It uses technology and advanced sensor to collect information, regulate agriculture production and monitor the process. Hydroponic smart farming is a method of growing crops without soil. When a plant is grown in soil, its roots are perpetually searching for the necessary nutrition to support the plant. If a plant's root system is exposed directly to water and nutrition, the plant does not have to exert any energy in sustaining itself. Plants grown hydroponically can actually grow faster and healthier than plants in soil because they don't have to fight soil-borne disease. Hydroponic farming gives the exact amount and type of nutrition that plant require at the precise moment, and it may be set up inside to maximize space. Hydroponic handles soil-related issues such as growing plants that require difficult to maintain soil condition, less weeding and were easier to harvest. When hydroponic and IoT are combined, this can result in a successful crop harvest and maybe better growth quality.
It's amazing how it's work.
We are using many sensors in this project. That's our pH sensor, temperature sensor and water sensor. So let me start with pH sensor. We use for detect pH level in tank. The range is from 5.00 to 7.00 can be read by this sensor. Secondly, we are using temperature sensor. The water temperature sensor enables the control unit to identify engine overheating or an unusual rise in temperature. Lastly, water sensor. We use this water sensor to detect the presence of water and when placed in location where water should not be present, a leak. When Wi-Fi is enabled, the sensor can send out a notification to the homeowner through a smartphone app. We control all the sensors with Node MCU8266. This Node MCU8266 has come up with Wi-Fi module. The function of this Node MCU8266 is to control whole process output and input, transmitting and receiving data.
Here the app that we use to monitor this project. The app name is MQTT-. In this app we have pH indicator. It will show pH range between 5 and 7. Then we have indicator for pump to detect volume in water pump. And also we indicator for motor R&B. We can set time there for mix fertilizer. We have indicator for water temperature. For clock set and data also we have indicator separately. We will get a notification through this app.
I'm super excited about this. Can I know more about this project?
We have many impact from this project. Hydroponic smart farming are able to manage pH, water temperature and nutrition to make sure plant get exact needed. With using low-cost sensors and IoT platforms, the efficiency and production will increase. When compared to traditional soil-grown crop, hydroponic smart farming has the following impact toward a new concept of agriculture. Firstly, we are go for real-time data and production insights. Farmers can visualize pH level, water temperature, and nutrition and more in this to accelerate decision making. Secondly, faster grow rate. This is entirely control over environment required for plant growth. The plant will be put in perfect condition where they can contact directly to root system. After that, optimal use of space. In this case, the production will increase 3 to 10 times in same amount of space. The plant will grow multiple when its root submerged in tank of oxygenated solution directly contact with vital mineral.
Not only that, we have many more. Next is, no soil involved. Since hydroponic farming involved growing plants without soil, that is very useful for who has limited accessibility to land. Indoor farming in a climate-controlled environment means, farmers can exist in place where weather and soil condition are not convenient for traditional food production. After that, optimal use of nutrients. Since all nutrients are readily available to the plant, their roots do not have to spend time and energy in looking for them. This way the plants grow healthier and larger because they tend to absorb all the nutrient much faster rate. Finally, less risk and volume of pests. Soil is the prime factor that contribute towards proliferation of pests in the garden. To protect our plants from pests we have to use pesticides or pest control products. It's harmful for environment. If we grow hydroponic plants there would be no pests and therefore the need of pesticides would be completely eliminated.
Firstly, the microcontroller which we have used in this project is NICOM2021. It's come up with Wi-Fi. This microcontroller will control all the input and outputs of this project. Next, we have used real-time clock module. Although keeping time can be done without NRTC. Using one has benefits. Low power consumption. It shows more accurate time compared to the time in Node MCU. The real-time clock will be connected to the Node MCU ESP8266. For input section we use pH sensor. Its calibration is 7.0, so the range is 5 to 7.0 can be read, and it's suitable for hydroponic criteria. Next sensor we used is waterproof temperature sensor. It is same as the normal temperature. We use this for detect the temperature of the water. Next we have water sensor. We used it for detect the volume of the water in the tank. For output section we have for channel 5 volts relay. It can control device from 5 volts till average of 250 V or AC. Then, we used motor water pump 12 volts. This is the doser A and doser B. The doser A and B it would pour vitamin A and B into the water tank. All the data from the ESP8266 and sensor will send to the cloud. In MQTT it must be setting the server. It will connect with the broker.mqtt.dashboard.com cloud server. From there it will get the real-time reading for each sensor. In terms of motor, pump and all we can schedule in this application. For example, you can see the reading of pH value of water in this application. The application will show you the exact value. In this application, it will make sure the tank is always full. If it's not full, the full indicator in the amp key will shows that is not full with the help of water sensor. So from there the main water pump will pump back the water to make sure that the water in the tank is always full. Next we got doser A and B for the vitamin and tested in the application. The time for vitamin can be scheduled for each time the vitamin that have to process in the hydroponics. In our project we have set the time at 10 p.m. So every day at 10 p.m. the vitamin will dose into tank. The electrical device is kept in a junction box. The sensing hardware involved 3 sensors, each strategically placed within the hydroponics farm located at the plant roots and water supply to collect data about the pH levels, water level, water temperature, and nutrient supply.
How is it, Kashwini?
This is very good idea and a slow very useful especially for this current situation. I'm going to tell about this to my father. He will very happy after he know about this idea.
Not only for your father, for all farmers this will be very helpful. That's why we do this project.
Okay guys. Good luck and all the best. Okay, I'm leaving. See you guys later. Bye.